Dear students, welcome and thank you for tuning in. We are starting a new lecture in the materials science class and in the biomaterials class, which is composites. We're going to learn about composites, what are the classes of and the types of composites, why are composites used instead of metal, ceramics or polymers in different engineering applications and also in medical applications as well. How do we estimate composite stiffness and strength? How can we quantify and estimate their properties, especially mechanical properties? Even though composites have a lot of their important properties to identify, especially heat transfer and electrical conductivity. Also, we want to identify some typical applications of composites in engineering and in medicine. A little bit of terminology and classifications. Composites, generally speaking, is considered to be a multi-phase material, at least two phases. We talked about phases and how can we distinguish different phases in previous lectures. It's a multi-phase material that exhibits significant proportion of the properties of both constituent phases so that we can get better combination of properties that we want for the specific application. This is the general definition of composites. So it's multi-phase material with different, with a mixture of properties from each phase. And a composite, recently in these days, nowadays, is a multi-phase material that is artificially made, as opposed to one that was occurs, naturally in nature, in nature. Also, we need to make sure that the constituent phases, they must be chemically dissimilar and separated by artificial interfaces, so they can be seen and they can be identified easily. So if we have a two-phase material, a two-phase composite, we will have two distinct phases. The first one is called the matrix, it's this one here, and the other one is called the dispersed phase. And these two phases are what makes the composite. So we're taking the simplest format or the simplest structure that we have a composite of only two phases. So the matrix, the property of the matrix is it's the continuous phase, and it is as opposed to the dispersed phase, which is going to be smaller in volume. So the matrix is going to be the big material that is that the dispersed phase, the material of the dispersed phase is immersed and dispersed inside the bigger matrix. And it's important to know that if the matrix is if we have only one phase, the matrix might have specific properties, but we are adding another phase into that material to enhance its mechanical, electrical, or thermal properties. So the purpose of the matrix is to transfer stress to other phases, protect the phases, and also protect the phases from the environment. So it's going to be the big, material that encompasses the dispersed phase. And we have classifications of the matrix phase. So we can have metal, ceramic, and also we can have ceramic, metal, ceramic, or polymer, metal, ceramics. And each one of them, each of these composites, so this is a composite of three materials. So each one of these composites has, can give us or enhance a specific set of properties. And that's where when we look at the dispersed phases, if we have, so this is in the matrix, the first phase is going to be the matrix phase. That's the notation and the classification. So here the metal is the matrix phase. In this composite here, the ceramic is the matrix phase, and in this composite here, the polymer is the matrix phase, and all the other phases are embedded inside that matrix phase. The second phase, if we have a two-phase composite, called dispersed phase, and the purpose of it is enhance matrix property. That's the most important one. So in MMC, which is metal, ceramics, because of this dispersed phases, the MNC, the other metal and the other ceramics, we can increase the yield strength, tensile strength, and the creep resistance. If you have a CMC, ceramics, metal, ceramics, we are increasing KC, which is related to the rate of fatigue crack growth, so it improves the fatigue resistance. And if it's PMC, polymer, metal, ceramic, we increase the elastic modulus, tensile strength, and creep resistance. So this is how we are, this is the big terminology that we're going to use from now on when we look at composites. We need to identify the matrix phase and the dispersed phase. Now, we have in composites, we have three main classifications. Actually, there are four, but we are going to talk about only three. So you can have something called particle reinforced composites, or fiber reinforced composites, or structural composites. There is a fourth category, but we're not going to talk about it, which is the nano composites. But we're going to focus only on the particle, fiber, and structural. So this is to the right here. This is a picture of a artificial composite, and you can see how the composite is being, woven fibers, and this is a cross-sectional view. So this is one of the simplest, composites that we can create. And but we're going to get into more details about what are the phases and how we are going to use those composites and their properties. Thank you for watching. Until the next video. Bye.